Hello everyone, it's Aaron. In this video, I'm going to explain classes and object aggregation. In Java, classes are basically custom data types. They are blueprints which tell the program the state of our new data type and how it behaves. To create a class, simply type public or private class, and then the name of your new class, capitalizing the first letter. The first part of the class are the fields. Fields define the state of your class and are usually private. In this example, we have an item class, which has the fields name, quantity, temp, and price. The next part of a class is the constructor method. These methods provide instructions for the program on how to initialize a new instance of this class. If there are certain properties you want every object within a certain class to have, you would define them here. The default constructor looks like this, and it's also called a no-argument constructor. Down here, we have a 4-argument constructor, so every new item will have a name, quantity, temperature, and price. In this project, we have quite a few object aggregation relationships. Aggregation is a relationship between two classes in which the aggregate class has ownership or has a different class. For example, our store class here has a produce aisle, and the produce aisle has items. When creating new objects in a class, the most efficient way to customize and retrieve its features is by creating getter and setter methods. In our item class, for example, here is a setter method which sets an item's price. It's written public void since it's not returning anything, set price, and then passes the variable price as a parameter. Then here inside its set of curly braces, it's saying this price for this instance of an item will be this double. Then here's a getter method for an item object's price. It's written public double since it's returning a double variable, get price, empty parentheses as it doesn't take any parameters. Then within its curly braces, it returns the price. You can also say return this price to be more specific if you prefer. To explain deep copies versus shallow copies, I'm going to go back to my array practice project. In this project, I have a method which creates a deep copy of an array of integers. This method is useful when you want to move or modify an array without actually changing the original array. This happens by creating a new address in memory for the copied array and its elements. A shallow copy would look like something like this. This just creates a new array called grade shallow with the elements pointing to the same memory address as the grades array. If I were to change one of the elements in the grades copy array, like so, it would change the deep copy array, but it would not change the original. But if I were to go into the grade shallow array and change one of the elements like this, it would not change the deep copies, but it would change the original arrays and the shallow copy. So in conclusion, if you want a deep copy of an object, you need to create a method which will do that. I think that's it for this video. I hope it's helpful. If you have any suggestions or additional comments, or if I missed something, please leave a comment. Thank you.